Hi, today I'm going to show you the DC Slope software from DC Software Company. DC Slope will help you to analyze slope stability problems for different soil types. You can also use it for rock slope stability. First of all, you have to open a new file. Here you get different templates with different options. You can use these templates, but for now I will open an imperative file. When you open an imperative file, you will get this screen. Here you have a menu, and here you have different buttons which you can also access from the menu. Here you can change design standard settings. This program is based on European standard. So if you go here, analysis standard, then you will find here the first two are German standards. This third one is Euro 7. It's well known. It is, I think, from Austria or probably can be also be from Swiss. I'm not sure. Then you can add also additional free design safety factors. Here, for example, I have set one for Ethiopia, my home country. For now, I will use this code. Here you can see for permanent nodes, temporary nodes, and very extreme nodes like earthquake and the lights. You have here safety factors for different load types. Here, for example, dead loads, here live load, here water pressure and earth pressure. Here you have safety factor for the resistance. You have for friction angle equation and Andreev equation, different safety factors according to the load case. So you can also change modify it manually. And after you choose your code, the next step is to choose which load case you want. For example, load case 1 is according to the DIN code of standard permanent load case. Load case 2 is temporary load case. Load case 3 is, as I explained before, for earthquake in the less extreme load cases. Then you can say here OK. Then you can define your ground surface. To define your ground surface, you have to this button. Then you click here, and here is the coordinate 0, 0. You can click here, left click, and then here left click, here also left click, and here also left click, and finally when you finish, click the right button, the right mouse button. Then you can give here a name for your soil layer, for example sand in my case. Here you can find different parameter suggestions. For example, here I can choose sand, dense sand, and the material properties will be filled for me automatically. I can also change the parameters according to investigation results. After that, when I click OK, and I have my ground surface with the soil layer together. The next step is to define sliding circles. For that, we have different options. First of all, I will show you the freehand circle method. With the freehand circle method, you define only one circle. You click here and you define the center of the circle, and you can choose which areas you want to analyze. For example, I will take this area, and I can modify the center and the radius here, and I can click here OK, and I have defined my slip circle, one slip circle, and I can analyze the results. Before analyzing, I need to save my file. I will save it with the name with some name. You can give it any name. Then you can analyze. Now I have the results. To see the results, I will go here. I will click this button, and for critical freehand circle, I will see the results. Here you can leave the default values for scale. So now for this slip circle, I have a value of 0.54, which is less than 1, and my slope is stable. If I want to find the minimum failure surface, then I need to click here, and I can here iterate center. I can move the center with 1 meter interval, and when the critical point is found, then this interval will be used to iterate around this critical point. Then I will choose OK, and then I will analyze the results. Now the analysis is finished. If I see the results again, as you see, I have a local failure of the slope, which to be expected when the slope is a little bit higher than the friction angle. Then I can make my slope a little bit flatter. I can make it, for example, like this. Then I can analyze again. Now I have the results again. I can take a look at the results. Now it's almost fulfilled, but since I can use here vegetation and the like, this will not be also critical. I will show you now a different method to define the slip circles. I will remove this one. You can also define a grid for the centers, and I will click here on the grid option, and I will click here and then here. Now I have a rectangular area. For this rectangular area, I can define the spacing between the points. I will choose here 0.5, for example, in order to make it the points close to each other. And I will click here OK. Now I have different center points. For this center points, I need to define the minimum radius. For example, for this point, I will define the minimum radius and the maximum radius. Then after that, I can do my analysis. In order to define the minimum radius, I need to click here. Then I will give here the minimum value of, for example, 5 meter and a maximum value of 20 meter. Now I can start analysis again. The analysis being done for every center point. As you see, it will turn red when it reaches the center point. it will take some time. Now it's finished. Now I have the results. I will click on this pen button again and I will display label all analyze region circle centers. I will leave the scale as it is. Now as you see, it's the same. This circle, this slip circle has a minimum safety factor. I can see that for every center, if I move here with this button clicked, I can see the circles and the corresponding safety factors. For example, here I have a big circle here, and the safety factor is around 0.31, and it's less than 1, and the safety factor is the safety of the sliding wedge is fulfilled. For this local, in order to avoid these local failures, sometimes you need to force the slip circles to pass through some points, for example, the foot of the slope. So for that matter, you have to use this button, and you have to define a point here with all circles with the center. With the centers will pass through this point. Now if I do the analysis again, now I have the same, more or less the same critical circle with a local failure. But if I see here, for example, the slip circle are not causing local failure, and the safety factors are under 1. Now if I don't need these local failures, so I can remove this point. Here. If I remove this point, then I don't have this local failure. But I can also leave it like this, and I can make an argument in my report that these failures are not critical because I will have a vegetation or some protection here above the slope. After this, we will see how to add additional layers. I will press escape. In order to add additional layers, you can use this button. I will click here, and I will draw a polyline here, and here. And finally, I will click the right mouse button, and I will give it a name for this layer. I will say, for example, clay. And I can choose from the parameter suggestion soft clay, which I find here, and I will say confirm, and I will press OK. And as you see, all the area below this line, including the area here, will be taken as to be a clay layer. If you don't wish this area to be a clay layer, so then you have to modify this layer so that you will have here a sand layer. Now, if I do the analysis again, and I will look at the results here. I have a different slip circle. This time, a slip circle going through a clay layer is critical and has a higher critical rate than other circles which pass through this sand layer. You can also define an additional soil layer in the same way. You can click here, polyline, and then you can click right line, right mouse button. Then you name it with a name, and you can choose also values from this parameter suggestion. Then you have your third layer. This way you can define too many layers. You can also define water level. In order to define water level, you can use this water level symbol, and you can draw in the same way as you define a ground layer or a soil layer. Then you click here. Then you can choose either a linear interpolation or interpolation of a curve. And then I will choose OK. Then I have my groundwater surface level. This groundwater surface level will be used to calculate the unit weight underwater, and also the pore pressure and the pore excess pressure. Now if I analyze again, now I have I think a different circle which is critical. As you see, this one is a soft clay layer with additional load from water pressure which acts on the slip circle. Then I have a more critical slip circle which is different from the ones we saw before. In addition, if you have a second seepage water level, if you think that this groundwater level is not critical, so you can define a second water level. I will click here in the same way as I defined the first water level, and I will choose OK. Now the analysis will be done with this water level. I mean the pore water pressure and the water pressure will be calculated with this groundwater level. I think this one will be taken to analyze the unit weight of the soil underwater. Now if I look at the results again, I have a relatively better safety factor. The previous one was approximately 1.3 something. Now it's lower because I have a second seepage layer which has a lower water level. I can also define artificial water pressure if I have some aquifer here which has a higher pressure, a higher water pressure. Then I can define using this button, and I will click here. Then the pressure will be applied to this soil boundary, soil layer boundary. And if I click again, then I will be able to give a water pressure here, a confined water pressure. And for this confined water pressure, the stability will be analyzed if I start here analysis cycle. With this pressure, the safety factor will be a little bit undermined. It has here increased to 1.6 because of this confined water pressure. I will remove this one, and I will remove also this one. Now we have seen most of the options available, but in case if stability is not fulfilled, we can use also anchors. on the slope. I can draw here anchor here. I can define the position of the anchor here, and I can define here the inclination of the anchor. Here I can define the amount of force it can carry, and here the limits. I can also define here the spacing along the slope, for example 2 meters. I can also give here pre-stressing distance limits if it's a pre-stressed anchor. Then I can here press OK. Now I have anchor here. I can also array too many anchors. For anchors to be effective here, I may need here a short clip there in order to resist the punching here. So I can define anchor this way if I calculate again. Now I have the results. I can look at the results. As you see, it was 1.6. Now I have relatively lower safety value, which is good because I have to be under 1. And if I add too many anchors here, then the safety factor will be fulfilled. I can also use stabilization columns to define stabilization columns. You do the same way. You click here if you have a column here, and you click here. Then you can define the diameter of the stabilization column, or the parameters. The compressive string is long-term coefficient of long-term string is compression, and coefficient of long-term string is tension. And then you can do the analysis again. You can also define the spacing accordingly. If you double click here, the horizontal distance or the horizontal spacing is 3 meters. You can increase or decrease it accordingly. Besides anchors and stabilization columns, you can also model a component, for example a wall, a concrete wall, because these concrete walls have a little bit higher shear strength, shear resistance. The slip surface will not be probably able to go through this wall. So if you define here a wall, slip circuits which pass through this element or component may not be critical. If I see the results here again, as you see, only here the local surface is not critical. Before I had this slip circle which passes through this clay layer. You can also add live loads and dead loads to your model. If I press this button and I click left click, I can define a distributed load. It can be, for example, traffic load or surcharge load. I can define a load group, for example, load group 1, and this node is, for example, live node. I can define where it starts and ends, and then here I can also define the value, and I say OK. Then I can define also additional nodes here. I cancel this one, define additional nodes. I will click here and click here, and it can be on the same group as the lab node, but this time I have that node and amount is probably a little bit less. Then I can define that way, this way. And now I have defined additional nodes. If I start analysis, this lab node will be considered if it's unfavorable. That nodes will be considered always. And now I have my result, which is the same as this circle here. In addition, we can also define point node, which has on the point, and we can group it in the same group. And we have a position, and we can define horizontal node, vertical node, and moment. I give it here a value, a vertical value, 100 kilonewton. So I can have also a point node. Right. Now we have seen most other options. We can also define, instead of a distributed load, we can remove, for example, I will press cap, and I will remove this node here. If I have a building here, I can define with this one, this button. I will use this button, and I will click here, and I will click here, and then I can define my weight per meter. I will use here, for example, 25 kilonewton per meter. And I have my building, which will be nice when I display the results. We have seen more also options here. Now I want to show you one more option. Besides the slip circles, you can also use sliding planes. In order to use sliding planes, first of all, let us remove these circle centers. I will choose them, and I will press delete key. Now I can use these sliding planes according to YANBO. I will press here. If I know that my header will occur in this soft clay layer, I will press here, for example, and I will press here, and I will let coordinates as it is. I will let us remove this wall from here because we don't need it. I will remove this wall here, and then we have to connect these points to the foot of the slope or somewhere here. I can also connect this point to this point, so I will choose the same button, and I will connect this point to this point, and I will connect this point to this point. The angle between these planes should be less than or less 180 degrees. Now I have defined my surface, header surface. I can also define lamellas. The lamellas are by default 1 meter, but I can choose here at the start of the sliding feather and at the end of the sliding plane. I can define a width of 0.5, for example, here. And if I choose OK, then I have my lamellas here. Now I can analysis, and I will find the results immediately for this sliding plane. If I see the results here, as you see, I have a safety factor or a ratio of driving forces to resistance. So 1.1.21, so it's greater than 1 and safety is not fulfilled. And now I can also change the inclination of these planes so that I can iterate this. I can investigate this area. In order to make that, I need to choose this button. Then I will click here and I will give the program some angle here. And with this angle, it will iterate with this distance. That means I have given the program this angle, and with this 0.1 interval, it will incline this plane like this, and also upward in this direction. I can also define here the same way. I choose this button and I will click here, and then I will click here, and then I will leave the interval and this plane will have different inclination, and this plane also. Now I have the option to investigate all these areas. If I run the analysis again, now I have the results. As you see, I have almost the same ratio, but other sliding planes are also analyzed. Lastly, I want to show you how you can print your results. You can see your results by clicking this button here, the page button. If you click here, you see here your assumptions, so their parameters, ground levels and soil layers, groundwater tables, buildings, anchors, or the input you have given will be listed here, and the partial safety factors you chose, and the method you used for analysis, and then the calculation results will be displayed here for each slice for the critical wedge or sliding body. You have the results for every lamella. If you go to the last page, you see that the analysis is not, or the results is not okay, and it's not stable. But after you do some reinforcement, and you have your results fulfilled, and you have also a graphical display of the results. Then you have two options or three more options to output the result. You can simply print this result to a printer, or you can export it to a Word file here, and you can here insert cover sheet. You can also change the descriptions here, and you can fill these names. Afterwards, then your file will be exported to a Word format. Now it's exporting, it will take some time. Now I have the file exported. I can't open it here. I have no license for Microsoft Word, but I can see the results. All the results are here. I can also print it in a PDF file. I can change in my printer setup to PDF. Then I will print the results here. I can print input data, results, and geometry graphics. I can also print it in color or black and white. And I will press OK, and I will leave the default scale values. Now I can save it with another name, result2. Now I have my results closed here, result2. If I open the file, then I have it in PDF format, which is, for my case, I think it's the best one. So you can use this way to report your results. I think the software is useful to analyze stability problems. Thank you for watching. See you next time.